All right, let's dive straight into this explainer where we're going to unpack the comprehensive 3-term mathematics roadmap for grade 3 students. Grade 3 is such a fascinating academic year. It's really this critical bridge where young learners transition from simply counting objects to truly understanding abstract mathematical logic. So today, we're going to walk through exactly how that incredible transformation is structured over an entire school year. Grounding our analysis today is the official Budget of Work curriculum document from the Department of Education, which proudly bears the Bagong Pilipinas seal. And let me tell you, this document isn't just a list of topics to get through. It's the definitive guide. It establishes the absolute ultimate standards for student success across the entire year. It literally tells us exactly what students need to know, when they need to know it, and exactly how they're going to prove they've learned it. To make sense of this highly detailed document, we've organized this explainer chronologically through the school year. We'll start with setting the math foundation, then move into Term 1, geometry and numbers. After that, we'll hit Term 2, measurement and data, followed by Term 3, complex operations, and finally, we'll wrap up with the Grade 3 journey. What's really brilliant about this chronological setup is how it illustrates concepts acting as deliberate building blocks. The curriculum doesn't just throw everything at the wall to see what sticks, right? It's a carefully sequenced timeline. It starts with basic numbers in Term 1, expands those concepts to real-world, physical applications in Term 2, and then finally reaches advanced, multi-step operations by Term 3. It's literally a continuous, upward staircase of learning. Section 1. Setting the math foundation. The ultimate numerical boundary. Before we even look at the specific terms, we have to establish the foundational goal that shadows this entire academic year. Notice this recurring magic number, 10,000. This is the ultimate numerical boundary grade 3 students absolutely must master. It pops up everywhere in the source text. Whether they're reading plain whole numbers, comparing digits, or dealing with actual Philippine currency, everything scales up to but doesn't exceed 10,000. It's the numerical sandbox they'll be playing in all year long. Section 2, Term 1, Geometry and Numbers, Building the Basics. So starting off the year, the focus is heavily on spatial recognition and building vital number sense. Instead of just running through a checklist of weeks, we can actually group the Term 1 focus into 2 crystal clear themes. First step, measurement and geometry. Here, students aren't just memorizing formulas, they're using physical square tile units to literally build and deduce the areas of squares and rectangles. They're also identifying points, lines, rays, and perpendicular lines. On the flip side, for number and algebra, they're dissecting those big 4-digit numbers up to 10,000 by their exact place value. Plus, they're learning ordinal numbers all the way up to the 100th position, which, by the way, is a massive leap from earlier grades, while practicing rounding and comparing those large numbers. The crucial takeaway here is that by the end of Term 1, these performance standards represent the exact destination. The curriculum demands a student who can confidently navigate spatial geometry, like drawing parallel lines and finding area, and mathematically manipulate, order, and compare numbers right up to our magic limit of 10,000. Essentially, they've built the engine, now they just need to learn how to drive the car. Section 3, Term 2, Measurement and Data, Math in the Real World. As we transition into Term 2, the curriculum pivots so beautifully. It takes those abstract ideas from the first few months and shows students how math applies directly to the physical world around them. Suddenly, that abstract 10,000 limit from Term 1 is applied to real things. Students are dealing with Philippine currency up to 10,000 pesos. They're doing hands-on tasks with balance scales to measure mass in grams, kilograms, and milligrams. They're grabbing tools to measure and estimate capacity, comparing containers using liters and milliliters. The numbers literally step off the page and into their hands. The source material makes it very clear that students aren't just doing theoretical math anymore. They're actively solving practical, everyday problems involving the addition and subtraction of money, both with and without regrouping. And it gets even more interactive than that. They're tasked with collecting real data through experiments with a small number of possible outcomes. Think rolling a die or tossing a coin. Now, when they conduct those experiments, they don't just record the data, they really have to analyze it. When interpreting single bar graphs and real-life data, the curriculum dictates that students learn to describe outcomes using an exact 5-step spectrum of probability. They categorize events logically, starting from impossible at the absolute bottom, moving up through less likely, equally likely, more likely, all the way up to certain. This is introducing some highly sophisticated critical thinking.
Wrapping up the second term, the performance standards require learners to actively measure the world around them, add and subtract big numbers in currency, and logically present their findings. By the time this term ends, they must be completely confident in building and interpreting tables and single bar graphs, whether they're horizontal or vertical. Section 4, Term 3, Complex Operations, Expanding the Toolbox.
All right, this is where the curriculum really ramps up the intensity to challenge students with complex operations and sophisticated visual logic. The training wheels are officially off. A fascinating competency introduced here requires students to essentially become code breakers. They have to determine missing terms by contrasting and generating distinct types of patterns. Specifically, they work with both repeating and increasing patterns as well as repeating and decreasing patterns. And they don't just solve them, they actually have to explain how to generate these complex, multi-layered sequences.
Beyond cracking those pattern codes, the core operations get noticeably harder. Students tackle the tough 6, 7, 8, and 9 multiplication and division tables. They dig deep into the specific properties of multiplication, like learning that 0 times anything is 0, or that changing the grouping of factors doesn't change the final product. They're adding and subtracting similar fractions using visual models. And in geometry, things get super dynamic. They don't just draw flat shapes, they have to describe the effect of a two-direction multi-step slide, which is translation, and identify and draw lines of symmetry to complete halved figures.
The final performance standards of the year truly prove just how far these students have come. These last hurdles require them to effortlessly multiply and divide using those 6 to 9 tables, estimate products by rounding to the nearest multiple of 10, and apply all those properties of multiplication we just talked about. It's a rigorous, comprehensive test of their newly expanded mathematical toolbox. Section 5. The Grade 3 Journey. The Ultimate Building Blocks. Bringing it all together, let's look at what this entire span truly represents for a learner's development, based on everything we've just unpacked. There's this one specific curriculum guideline from the third term that brilliantly captures the core philosophy of the entire year. By asking students to illustrate division as equal jumps on a number line and as the inverse of multiplication, the framework focuses heavily on deep conceptual understanding rather than just rote memorization. They aren't just blindly memorizing math facts, they're being taught exactly how numbers behave and relate to one another in physical space.
So, we want to leave you with this final thought to ponder. When you step back and look at the sheer breadth of what is accomplished in this 10-month span, you really have to ask yourself, how does mastering these interconnected building blocks, going from basic counting up to 10,000 all the way to predicting probability and applying geometric translations, shape a student's lifelong capability for logical thought? Because clearly, this Grade 3 curriculum isn't just about passing a simple math test. It is meticulously, intentionally structured to build the absolute ultimate foundation for all future math, science, and data literacy. It is quite literally wiring the brain for problem solving.